All right, so a couple of things as we're going to start out. We have 2 weeks left, which is kind of amazing this semester. Sometimes it seems like it's flying by. Sometimes it seems like it has went very slowly. It's been a crazy, weird semester full of all kinds of unexpected surprises. So what we're going to do in the next couple of weeks is hopefully some of the more fun pieces. So once we got some of the fundamentals, so for example, we're going to work on some graphics this week. And how to use something called Turtle Graphics. Natively Python, one of the things it doesn't do very well is it doesn't have all these abilities to do GUIs, but enough people have created overlays and different pieces, so we'll take a look at that. So first I want to look at the discussion board for this week. So if you scroll down to week 14 discussion board, I did something a little differently. So we're going to call this Amnesty Week on the discussion board. However, I will substitute in a passing grade for a missing assignment. So read these instructions carefully, what the missing assignment is, and you have to create a funny, not true, not obscene reason for why you could not do this assignment. So entertain me, and I will substitute in one grade that you tell me about in here for a missing one. Okay? So, already I see that somebody has posted one in there. So these are kind of fun. People will get some interesting pieces in there. Alright, so we have this week, next week, and then a final. So, because this class is a blended class, your final will be available online. I am not making the on-campus section turn up for the final. That would be kind of an unfair piece. So we are going to do the final online in this course. So we will go over it then, not this week, but next week we'll dedicate some time to talking about what's on the final. So let's take a look at week 14 and take a look at what we're doing. So we have a couple of assignments due. I did not even put a quiz in for this week, so there is no quiz. There is only the 3 assignments and the discussion board, which again, hopefully you will have some fun with. It's always in the wrong one. There we go. All right, so we like the idea of graphics. Graphics make us feel good, and some languages, so if we go very rudimentary, some of you may have used something in high school or even grade school like Alice that really was based on graphics. And I've looked at some programming apps that work on our iPhones or on Android devices that make it kind of like snap together modules. But I think you need to understand behind the scene what's going on before we start giving you those kinds of tools. So what we're going to do this week is we're going to take a look at a couple of different types of graphics. And so one of them we're going to look at is something called Turtle Graphics Toolkit. So Turtle Graphics are an addition. Somebody has went out and wrote this. It's open source, which means anybody can use it. It doesn't cost us anything. But it was originally written, so a long before Python was even invented, the idea behind Python or behind Turtle Graphics. So in other words, what you're trying to do is very similar to what you would do if you had a turtle crawling around on your screen, is where it came from. Your graphics, so they're based on the idea of a Cartesian plane. In other words, those x, y coordinates. So 0, 0 is at the center, and so negative numbers, we can go to all 4 different quadrants. And then we say, hey, we're going to move from this position to another. So you can have things like a heading. So in other words, you're telling it what direction. So you can think about like a compass. So a compass starts at 0 degrees. So north is 90. And then we rotate clockwise to get around the rest of that. We can change colors to any one of the RGB colors, and we'll talk about what RGB is. Width, you can say how far or how wide you're going to be. And then you can also write whether the pen is down or up. So in other words, you're controlling where this object tracks across the screen. In that, you're then controlling whether it's drawing or not and different attributes about that drawing piece. So, let's talk about our turtle and give you a reference really quick about turtle. So, if I do something like this, t equals turtle, we're creating a new object. And it opens its new window. So, come back here. So, different things we can do. So, t dot down lowers the pen. Set heading, left, right, go to, forward. These are really pretty common sense once we start thinking about we're creating this object called turtle that's crawling around in our screen. And then we have some other ones. So this is a really good reference. In your book, they have this and some other ones. But this is kind of our quick reference of how do we find how to do things like that. So we can actually then also pull back information like where the turtle is currently at, what its current heading is, if the pin is down or up. So this is not the most sophisticated way that we can draw, but it is one way we can do that. So if we run turtle outside of our sandbox here inside of Cengage, you actually are going to have to set up a configuration file. So that configuration file says, how big a drawing area am I using? And so this is honestly probably the easiest way. In this config file, it's going to have these items. Now, we can add a lot of other ones, but this is kind of that idea behind the scene of I'm creating a box and it's got these attributes. So again, turtle's doesn't automatically pull in areas, but this is what turtle will look like when you're done. So here's our turtle in the screen. Here we can show what happens once we start drawing in it. So this is an example of a turtle graphic there. So it can do a lot of really neat things, and if you looked at like Etch-a-Sketches and those kinds of things, so here's an example of a code where we let the turtle walk around randomly. And so we end up with something like this. Let's talk about, some of you may have heard the term RGB before, red, green, blue. That's how we mix these colors on our screen. Well, each component in red, green, and blue can have between 0 and 255. In other words, it's a 2 to the 8th power or a 1 byte of each one. So colors then, if I look at that and I multiply 255 times 255 times 255, I get a really large number, around 16.7 million colors. And that's how we can represent different colors. It's the same way your monitor works. It's the same way if you have a fancy gaming system and you have graphic lights inside of it where you pull colors. So these are some of the basic colors. So here's our 16.7 million different colors we can create. So black, in other words, the absence of colors, all zeros. White, which is a mixture of all three colors. There's our value for white. And so in between are all of our different colors. And you can certainly look at those as we develop them. So there's a lot of examples in here. Here we've got it. Radial patterns with fill colors. So we're going to start out, and the easiest way to start this out is then inside of our assignment here. So I actually have a sample for 7.2, but we're going to click on 7.1 to start with. Maybe. Load. Go Cengage. And we're going to see if we can complete this some point inside of Cengage. Some point it's going to do it. Alright, so when I open this, you'll notice that this looks a little different because we have an extra piece in here, right? So we have this terminal in here, and then over here on the right-hand side, we have another space called our desktop. So Couple of things that it's going to do in here. So, when we get a file, we're going to create this one called ccurve.py. Alright. Recursive patterns in fractals. And we've all seen fractals where we essentially build things. So, what we're going to do is build something that starts like this. And we have different levels of recursion. In other words, the more recursion, the more complicated our fractal pattern becomes. All right. Here it says, don't enter 1 over 10, although even it says do enter, because it tends to break this. So, this one is actually a case study. Here's the great part. You're not even graded on it. But I want you to see how we do these things. So, here's our proposed interface, and again, I can blow it up. So, enter the level, and then we can actually look at that interface, how it's going to work. And we know that these are going to be recursive. In other words, they call themselves to reiterate each fractal. So, all right, let me see if I can make this a little easier. That way. All right, show a little more screen. All right. There we go. All right. So try to show a little more screen here so you guys can see what's going on. So this is one area Python, I think, lacks a little bit compared to a couple of other languages I can think of off the top. Graphics are not native to it. So because of that, we have to use a lot of times third-party portions. And so the first thing we're going to do, we're going to import our math function. So we know that we're going to do some math functions. Let's grab it and go. And then, from the file turtle, we're going to import turtle. So now we've got turtle loaded into our system once this program runs. And because we like the idea of functions, we're also going to create a function. So we're going to call our function from, so if name then we're going to run main. So we can call our main function, and so we know our main, we're going to define our main function. And we're going to set a couple parameters in main. So we want to create a couple of things. So we want to create a circle here to start with. So let's think about what we have to do a circle. We need to know a radius and a starting point. So I'm going to use X, and I'm going to use Y to set our circle. And I'm just going to set them both at 25 for now. Sets it in a location. I'm going to set something called radius. In other words, from the center to the edge of the circle, I want to see how big that's going to be. So let's set that equal to, let's do 100 units. And then we're going to call a function called draw a circle. All right. So to draw a circle, we need to call that function turtle. Capitalize it. All right, so we're going to call turtle. So turtle gets passed in some information. X, y radius. So in other words, we're going to call this function draw circle, which also calls draw turtle function, and then it passes x, y, and the radius. So if we're passing them into a function called draw circle, we need to get a function called draw circle. Now, because we're passing in that turtle, we're going to pass that in as t, x, y, radius. So all of these items come in. So this turtle comes in as t. All right, so now we have to figure out how to draw our circle. So all right, so we're going to be at this indent level, so our function is all here. So t dot up. So in other words, the pen is up because we don't want to draw from wherever it happens to be to our center. And then we're going to use a t dot go to. Now, I want to put it not at the center of our circle, but I want to put it somewhere on the circle. So I'm going to put it on the circle, but to the right. And so I'm going to say that I'm going to go to x plus my radius and y. So that sets, instead of where our center is, it moves it whatever that diameter is. All right. Then I'm going to do t dot set heading, and I'm going to set that for 90 degrees, which should go up. And then I'm going to put the pen down, t dot down. Now, pen is down, it's on a spot on the radius. Now, we have to come up with a formula to do this. So I'm going to break it into 3-degree arcs. We should be able to see that it's a circle, even though we broke it into 3-degree arcs. In that case, what I'm saying is I'm breaking 360 degrees into 120 units. So rather than do 360, we're going to do it in a little bigger chunks. And you'll see when we run this how slow it is, why we might want to do that. So we're going to say t dot left. So it's going to go 3 units left. And then we're going to go forward. And here we're just assume a function. So we're going to use math.pi. So 2 pi times our radius. And then we're going to divide that all by 120. So it's a formula. Let's just take it for what it is for now, and then we'll look at it when we run it and see if this actually will work. All right. So I'm going to run this, and if I bring this open over here, run, try it again. Look at that. There goes our circle. So it draws, but we see some issues with it, don't you? So it does work. It doesn't stay on the screen, which is kind of annoying. And what that tells us is as soon as this function gets done, it essentially dies. It runs this function and then goes, oh, nope, we're done. So we can try a couple of different things. So we can try putting in our input. Aha, look at that. Because what happened is it reached the end of the program and it just exited. It said, all right, I'm done. I'm going to exit. Life is good. So the shape is our turtle. So if I had not, and so here's where it's kind of interesting to try things. If I had not moved it originally over here plus that radius, let's take a look and see what happens. So it created a circle, and it's hard to say because I can't put these over each other and show you, but what it did was, instead of moving over and then creating the circle, it created the circle based on that origin point. So our origin point would actually start somewhere different. And you can see that if you actually did this. So let's just remark this one out. And you can actually see the turtle wandering around. So let's do x plus radius. And then we'll run it. So you can see that it started here, and then said, oh, I got to go over here and find this point on the circle. Now, it doesn't look like it really started at the right spot, but sometimes the turtle is in weird positions based on previous coding. So if I ran it again, it may look a little different. If I changed where that radius is, so let's go slightly different. Let's go 50, and let's go 75. You can run it again. So notice we made it actually worse because we said here's our radius. If we actually put those at 0 and 0, let's see what happens. Now you can see that it started in the right location. So when we started it down and otherwise, it always wanted to go to this position at 90 degrees. So got a whole bunch of these open because I was playing there. All right, so that's kind of our start of how we can play with turtle graphics. Now, that's not all we can do, obviously, but that gives us an idea of a couple of the things that we can start with inside of our little turtle graphics. So, our circle is one option. So, this case study starts talking about doing some curves. Well, we can look at some of those curves and also start functioning with those. So, all right. So, if I also want to run this program external, then I also need to have that configuration file. So, Turtle's really easy to get. The configuration file, so here, that's that width, height, using idle, yes, we want that, and color mode. So, we can actually change colors on those if we wanted to. So we can add a lot of different pieces to. So this is a little more involved. Make that bigger so we can see it. So this is an example of those fractals, and in this case it actually did change some colors. So if I close that and run it again. So if I did 15, let's see what happens. So it's so small you're not even going to be able to see it, but it's recursing back through those. So let's try like a 6 or something smaller, and you can see it there. Yeah. So we can take that turtle, we can make it move, we can do a lot of different pieces with it. So this is kind of an introduction to the graphics that are inside of, or that we can use. So here is a sample code for 7.2. And so what I'm going to do is I want to open idle, and I'm going to take this code that we have, and I'm going to copy it. So we can take a look and see what it's doing. Copy. And then I'm going to put it into a new batch script. Now, when I copy out of there, especially out of Blackboard, I always have to be careful. Did it do anything really weird? So I got to check my indents really carefully. All right. So this is an example taking that same idea. Now we're going to create some of those fractal curves. So if I look at this, it's saying I'm going to take random colors. So pen color is going to be random. Well, if I wanted to eliminate that and I just wanted to put in 3 colors, I could certainly do that. So I could do this. And I could put in, so 0, 0, 0 will be black. All right. But let's watch what happens when I run this. So first I have to save it. Run module. Yes. And I'm going to save it in Documents under Python Files, so I know where it's at. I think I have one named that, so curve. And when I run this, it's going to say, wait a minute, what happened here? Turtle's not defined. Oh. Okay, so a couple of things I have to do here to make this actually function. So I need that turtle configuration file, and so I need to create that. So I'm going to edit with Notepad++, because I have it happen to be right there. So here's my turtle.config file. And so now I need to save that in the same location as so I got to go to my documents, and I should have documents. I should have a Python folder, and so I'm going to save that there. Close that out. All right, let's see if that was enough to get our file to run. All right, so the other piece that we sometimes have to do is we're going to have to go and import that turtle function. So rather than do that on this computer directly, here's what I'm going to do. I'm going to run it then inside of wherever I happen to have one open. We'll do this one. I'm going to run this inside of Cengage here, just because it's handy and I know it's already pre-set up. And then I don't have to worry about getting it to load on every machine. Alright, so give me my sandbox. Alright, so I'm going to take this function then here, and I can then force it to run inside of here. And it may not like what I've done, but probably put something weird in there. So, but we can run that turtle inside of there. I was trying to hurry and show you guys what it would look like. So that's actually for 7.2, and I don't think I have the code in there. So when you do this one, I encourage you to take a look and see, hey, what else can I do in here? Try to experiment with them. I'm looking for, come on, go Cengage. Go Cengage. Sometime in the next century. Alright, so what we're trying to do is change this one enough that you can create it in it will create those curves for you. I may have broken Cengage here right in a second. That it'll create those in colors. And we know how to do the random, so we're taking some existing code and we're trying to make that work for us. All right. The third assignment we have, now that I've managed to make Cengage not work, see if we can really break Cengage and try this again. All right. So this is creating something called a Coke snowflake. So we're taking a small shape, we're adding additional pieces until we get something like this that we've created, a kind of a unique looking snowflake. So when we read the directions here, we're going to use a function. And so we're going to write a function called draw fractal line. And we're going to take a point and we're going to move from that a given distance and a given direction. So what it should look like is when you ask it, you're going to have a height of a width of 200 by 200 and 150 for the size and a level 4. So that's going to get passed out of the main into this function draw fractal line. That draw fractal line is going to call itself repeatedly to draw our snowflake. So in other words, it's going to move up and create one element and then call itself repeatedly. So what it should look like then when we're done is we're not going to take any user inputs. It's going to just draw this for us based on the elements that we put into that main. So a couple of things we can start with, because we know that we're going to need to call our function originally. So we know that we're going to have to come down here and we're going to create our main. So if underscore name equals so same thing we always start our programs without, we're going to call the function main. Our main function, so define main, we don't push anything into it, so it's just an open function. And we know that it's going to call something to create this fractal. So that fractal line is going to be one of our functions in here. But I think we probably should break it into a couple of other pieces. So I know that I'm going to have up here, define a function called draw fractal line. And we know that because here it says here we're going to use a function called draw fractal line. And I don't know what yet I'm going to pass in and out of that. So I might want to be a little cautious. I may also know that I'm probably going to have a couple of other pieces in here. So draw fractal line, but maybe I'm also going to have one where we're actually going to create this Coke fractal. So each line is specified. So define draw Coke fractal. Now, to rotate this around, we're also going to need something like a rectangular polar conversion. In other words, some way that we can rotate this into becoming a circular function. So So maybe something like draw a polar line. And polar just tells us in this case that we're going to be rotating around a specific point. All right. All right. So we know that it's an equilateral triangle. At level 1, each line segment is split into 4 parts. All right. Figure 7.5 shows these shapes at level 0, 1, 2. So, 3 levels of a Koch snowflake. At the top level, the script uses a function draw fractal line. Initial angles are 0, negative 120, and 120. So in other words, it starts at 0, goes counterclockwise, and then goes clockwise. Right? Initial distance can be any size, such as 200 pixels. And we're going to call it, so, if the level is 0, the turtle moves to the given distance in the given direction. Otherwise, the function draws 4 fractal lines with 1/3 of the given distance, angles that produce the given effect, and the given level minus 1. Ooh. Okay. So let's see if we can come up with a couple of these pieces here. All right. So let's look at our draw fractal line first. So I know that coming into here, we're going to get a couple of different pieces. So we're going to pass in, tell me on my name. There it is. So the width, height, size, and level. Okay. So width, height, size, and level. So I could come down here on my main, and on my main I could call so draw Koch fractal. So we're going to pass that up into this one right here. So draw Koch fractal. And that draw Koch fractal, we're going to give it a bunch of information. So we're going to give it that width. We're going to give it its height. We're going to give it its size. And we're going to give it a level. So if I'm passing 4 pieces into Koch fractal, then up here, I know that I'm going to take in 4 pieces. So I'm going to take in the width. I'm going to take in the height, size, and level. And notice I didn't just call those a value. I could have and passed them in, but I want to explicitly show you that we're passing in those by value. So it's passing in those numbers into this fractal function. So this is where we're going to create a couple of our pieces. So I'm going to call our little turtle function. So t equals turtle. So now I can use that dot notation. Now, really important, if I'm going to use that turtle function up at the very top of my header, I probably need to import that turtle. So I'm going to go look for a file called turtle, and I'm going to import turtle. I'm going to also grab a couple of other pieces. I'm going to grab one called tracer and one called update. I also know that I'm going to use math functions in here. So import math. We'll see if that's enough. I typically also, if I'm going to do anything with random numbers, and I'm going to go import random. In fact, I typically import random into everything because I never know when I'm going to use something randomly. All right, so I know that I'm going to pass these values into this Koch fractal. I'm going to call my turtle function so I get him available. Well, the first thing I'm going to do, though, is I'm going to hide my turtle. So I want him to move without being seen, so you're not seeing it scroll across the screen. So I want my pen up, and I want to go to a specific location to start with. So I'm going to go to, so I want to figure out kind of in the middle of where this is all at. So minus width. Now to create that as a integer, I'm going to use my double divide sign. And I'm going to do the same thing. I'm going to take my height, and I'm also going to, but I think I'm going to use, well, we can use 3. It doesn't really matter. So I want to divide that up. So I'm in kind of the center-ish of my area. All right. So now I've drawn. So now I'm going to put my pen down. So I'm going to put down. So we've moved our turtle, and now we're going to get ready to actually draw that. Well, one of the things that it says we're going to do is we're going to use something called that draw fractal line. Oh, it's right up here, and we haven't used it yet. So let's call that function draw fractal line. And what we haven't looked at is what we're going to pass in there yet. So we're going to pass in a set of values. We're going to pass in t. We're going to pass in size, 0, and level. All right, so we got the size, we got the level, we've created a new starting spot, and this t then is this information in our turtle passed in there. All right, so that's going to start us at our first location. It actually said we're going to do it 3 times. Where did I see that? All right, here it is. The initial angles are 0, negative 120, and 120 degrees. So that's our 0 right here. So we passed in 0 degrees. So I'm going to do the same thing, but I'm going to change it just slightly. So I'm going to pass in t, size 0, but now I'm going to pass in negative 120, and I'm going to pass in a positive 120. All right. So when I call this draw fractal line, I'm going to pass all this information in. All right. So if I'm going to do that, I need to take in those values. So I need to take in a couple of things there. So I need my t, we're passing in. So we're also passing in, we're going to use it as distance, but it's the same as the size. And I want to pass this in, but I'm going to call it a slightly different name. I'm going to call it theta, and that's going to be our angle. And then finally we have to pass in that level. So we're passing numbers back in here, so just remember that, so we can call them whatever we need to. All right, so now this is where we have to make a decision. So remember that over here it says, if the level is 0, then the turtle moves the given distance in the given direction. Otherwise, the function draws 4 fractal lines with a third of the given distance, angles that produce the given effect, and the given level minus 1. Blah. A decision based on the level. So I remember what I'm doing with that. So decisions are almost always if statements. So if is equal to 0, well then, so if that level is equal to 0, if I can get my colon in the right spot there. All right, so if level equals to 0, then all we're going to do is we're going to draw a line. And notice I already created a function called draw polar line, so we're just going to call that one draw polar line. And what we're going to pass into that then is we're going to pass in t, our turtle, and we're going to pass in then our distance, so how long it is, and that theta, in other words, the angle. So if we put in a 0 for it, that's what we're going to get. Otherwise, so else then says any other condition, so any other level, we're going to draw this 4 times. Right? 4 fractal lines with a third of the given distance, angles that produce a given effect, and the given level minus 1. Ugh. All right. So, a third of the given distance, and blah, blah, blah. All right, so we need to do the same thing. We're going to draw that polar line. And we're going to change some of those values. However, maybe what we really are going to do is maybe we call back our own function. And so that's where it gets a little bizarre. So what if, so we're in the function draw fractal line. What happens if we call our own fractal line back? So it's going to come through here, and it's going to call itself back. So let's see what happens if we do this. So draw fractal line. So that takes 4 elements. So if I come back, see if I can make it a little more visible. Okay. So fractal line takes 4 elements: t, distance, theta, and level. All right. So draw fractal line is going to take t. It's going to take the distance. But if I look over here, it says a third of the given distance. Well, I don't want fractional values in there, so I'm going to do it this way. So our angle, and then finally we're going to take 1 off that level. All right. And it says to do that then 4 fractal lines. Okay, so if I'm going to do those 4 times around, I need to angle them around so it rotates a little bit. So I'm going to copy this so I can do it 4 times. One, 2, 3. All right. So now I have 4 times. I'm calling that fractal line. The distance doesn't change because that's the same thing. However, if I don't change this angle, if I don't change that angle, it's going to stay the same. So we need to change this angle in some way. So let's take a look, and we could come up with an angle. So let's go, we started at essentially at whatever we get passed in. Let's add 90 to it and see if that works. Well, if we're going to add 90, let's take 90 back out. And then we're going to do it at the same level and see if we've rotated enough around to do that. All right. So we have a lot of our functions in here, except we have one weird function that we haven't talked about yet. Draw polar line. All right. So draw polar line really is just going to draw a single direction. So draws or moves a given distance, a given angle. So in other words, all this does is we pop in some information and it says, all right, I'm going to set heading, and we're going to take that value in, We're going to call it that theta just so I don't confuse it with anything else. And t dot forward, in other words, our distance. So I need to then take in a couple of things. So because I'm using that t, or the turtle function, I've got to pass that in. And theta. All right. Blah. All right. So let's take a look at this really quickly and make sure. Trying to think if there's anything else I need to put in here. So fractal, my turtle, draw fractal should pass in. All right. Let's see what disaster happens from my typing and what syntax error I will get now. Bad input on line 40. Okay. If name equals name. What did I do there? Alright. Well, I did something. I don't think it quite did what I wanted, so I may need to play around here with a little bit. It created something, and if I zoom in, it doesn't look very pretty. So, let's change some of those numbers and see what happens. So if I put in a 3, oh, okay, it did make something a little different. Something's still not quite right, but let's just play around here a little bit. We can see what we can run here. So there's with 2, and if we put in a level 1, 1 should just give us a triangle. It did, sort of, but we have these extra lines sticking out, so something's not quite right with our coding here. So let's go back to 4. All right, so maybe we need to change some of our values. So one that I'm suspicious about here is, let's see what happens if we change this one to, let's see, 90, 90, 90. Let's go 60s. So I didn't change anything other than that value. Let's see what it looks like. Oh, okay. So 90 rotated an entire quarter, whereas 60 rotates it so that we end up with a nice set of arrangements around there. All right. So what happens if we change that again? So maybe we can even play with it and say, what happens if we change it to 30 and 30? Well, that got interesting. It's an interesting shape, not what we're looking for, but if we do 60 and 60 both directions, and then remember that this recurses over itself multiple times to create that, we end up with something that looks like that. We can change this, and we can see what happens if we have a 1 in there. If I have a 1, now I get a star. Oh, man, we're getting something weird. So we're not quite there. We've got something not quite right. But it's interesting what it's doing. So level 2, level 3, and level 4. So we need to do a little bit of tweaking. And in fact, I suspect if we come over here and we run our checks, let's see what it does. It may give us a hint on what kind of issues we're having or what might be wrong. One thing I will say, well, it doesn't like that at all. All right, so we'll look at what it's telling us. One thing I will say that, and I've discovered a couple of students, so the functions, especially if it specifically asks for them for a name, use that name, because a lot of times the code is specifically keyed on that. And so even though it may look like it works, program generates the correct image. That's not very helpful. Program produces the correct image. All right. So if I go back to my directions, it says this is what I should be getting. Well, what I notice is those are my first, are the correct levels that we're getting, because we're seeing this as level 2, level 3, but we're not quite right. So somewhere in here where we're changing those levels, we've got to figure out what's going on, because it's taking those levels differently. So we have an issue somewhere in here where we're saying level 4, and it looks like, well, let me see, a level 3 in ours looks like a level 4 on the description. So we're off somehow on our levels. And so we may need to come back here and look about what we're doing. So let's see here. So can draw fractal line change that. So if level equals 0, draw polar line t, distance theta. Okay. That shouldn't change anything. T, distance, theta, level -1, level -1, level -1. So interestingly, we're taking our -1 here. So maybe something else in here. So draw fractal line, t size 0 level, t size level. So maybe we try coming in here and we take out a -1 here instead. It doesn't hurt to try it, and we might be able to get something slightly different. So that gave us, is that the correct image for, looks much closer. So I might try that again and see if that passed my check. And it still doesn't like me. All right. So we have a little tweaking to do on this. We'll have to figure out why it doesn't like that particular thing. So go to, let's try moving it over just slightly. Maybe that will make it happier. So now we're a little closer to the center. Let's see if it's trying to overlap them. So, oh, I don't want to do that. I want to go backwards and run checks. All right. So we're going to have to do a little investigation here, because what it's trying to do is match those images that we've got. And so those images we're looking for levels 1, 2, and 3, or 0, 1, and 2. So 0, 1, and 2. So we need to come up with a way to manipulate ours to get to that. So that didn't work. So we may need to do a little more tweaking to figure out how we can get those images then to match. So draw. Did we do the ones that they asked? Width, height, size, level 4. All right. So that looks correct. That looks correct. All right. So this will take a little bit of tweaking, and I know you guys have ran into this before. So it's going to say, hey, this doesn't match. So probably not. Oh, what did I do different? It liked me for some reason, and I'm not even sure what I did different. So something in here. Interesting. Oh, when I did, I was trying to do that. Maybe that's enough to, well, let's see. I was trying to see if we could center it a little better. Let's see if that, Makes a difference. Sometimes the... Well, that's apparently enough. All right. So sometimes the testing of this is a little interesting because it's looking at specific items. So now that we see what it should look like, now we can try it and see, does that work with a level 0? What happens? We get a triangle because it's drawing it 3 times and just making a circle around there. So if we did it with a level 2 or 1, then we should see so, and you can play with this. You could try a level 6 and see what happens. It's probably not going, because we only have it doing 4 times, so it's going to shove it into a tiny, tiny little box. So level 3. Level 4. So you can experiment with it that way. And level 5, yeah, it's going to shove it all into one little, collapse it all in there. All right. So that's our assignments this week. So what I'd like to use this week for is, A, you get 1 free assignment on 1 pass. So there's a discussion board for that. I would love it if everybody could go through and get everything caught up, and that way everybody gets an A. My hope is, at the end of the semester, all I turn in are A's for this class. So let's use Thursday then as a work day. I will be available in class or online. If you want to message me at that particular time, I can set up a Zoom session or something else. And let's get everybody caught up. We have 1 more week of assignments, so if you look ahead for assignments, so 1 more week, and we talk about classes and objects. So we start putting this into kind of a bigger construct. In other words, what do classes and what do objects look like? So I don't have a ton for next week, so let's get everything caught up, and then we'll also practice and show you what's going to be on the final. All right, any questions? Going once, going twice.